More than $10,000? Okay, let's start with Solana. Um, less than $10? Less than 100? 1,000? 10,000? Okay, and of course, ICP, less than $10? 100, 1,000, 10,000. So I'm not going to reveal the answer just yet. I want you to stay tuned. We're going to cover that in a little bit. And I'll also tell you what is there is a reason why I'm asking this question. I'm not trying to compare one chain with the other or trying to show like one is better than others, but I'll give you a little bit of a context of what I'm trying to do here. So this is not a trivia question, by the way. This is how it works, right? How does a Web3 app work today? So less than 1% of the app runs on blockchain, and 99% of it does not run on blockchain. So when we say what is running on a blockchain, it's basically the token ledger, which is like, just to simplify it, you have a from address, to address, and an amount of like somebody sending certain tokens to someone else and the amount. Everything else typically runs on like some centralized cloud. AWS, Cloudflare uses all the centralized stack, so on and so forth. That is not a trivia, that's a fact. Now, why is that a problem? So let's think about it, right? So as we are using all of this centralized infrastructure, when someone says, my app or my game is running on a blockchain, what does that even mean? So I challenge them, just ask the developer to take their credit card out of that AWS account, and let's see what happens to the game. It would just disappear. That's the problem we have today. So we have a false sense of blockchain apps being trustless. They are stoppable, immutable, hackable, and censorable. How? So a developer could simply stop paying for that AWS account, and the app disappears. Yes, you have your NFTs and your tokens still live on the blockchain, but what's the use? What's the point? You were using maybe certain NFTs you earned in some game. If the game is gone, like the usefulness of your token also disappeared. The developers who are running that front-end experience have the power to modify it at any point in time on their own. Of course, it's censorable because cloud governments, they have an off switch, a perpetual off switch. They can change the rules at any point in time and do that. And of course, it's hackable, as we see with these bridges getting hacked every time and so on and so forth. So the question we started asking ourselves, and this is a project we started back in around 2015 is when we started working on it. So can a blockchain be extended from running a token ledger, which is the from, to, and amount, to running the entirety of humanity's software? Can we build a trustless world computer where everything can be built completely on-chain? So presenting to you ICP, or the Internet Computer Protocol. So ICP is a complete reimagination of the blockchain stack. So we are not trying to say we are faster, better, Ethereum, and all that kind of stuff. We're just trying to say, OK, this is how it works. So first of all, we started with a sovereign physical hardware. So the internet computer completely runs on like server-grade node machines, which are owned and operated by independent people, globally distributed, like different geographies, different jurisdictions. None of these nodes run on any centralized cloud. It's completely sovereign from ground up. This is the most interesting thing that we have basically on how we solve this. So the internet computer is run by a governance DAO. What it does is it orchestrates the topology of the network to ensure that there's sufficient decentralization, and you don't need to do unnecessary replication. I'll give you an example of what that means, right? So typically, every data, every aspect on something like Ethereum is replicated 800,000 times, give and take, close to 1 million times. On the other hand, when you think about your, let's say if you're building a game, a blockchain game or an app, that is like replicated on your centralized AWS cloud probably 2 times, 3 times, 4 times, something like that. So why is it that we have this token replicated almost 1 million times, and this app that you built probably replicated 3, 4 times? Right? So what we did was like, can we create an infrastructure that can essentially enable one to provide just enough replication depending on the kind of application you're trying to build. And the third thing we do is like we do sharded execution with subnets. So ICP can horizontally scale, completely unbounded capacity. You just keep on adding these machines and start creating unbound capacity. And these subnets can interoperate with each other simply by doing a function call. So each of them is fully interoperable. Are you guys able to hear me OK? I'm seeing a lot of echo. OK, awesome. All right, so here's what we are trying to do. So ICP is the cloud for crypto. It helps you build almost anything. So online systems and services can be built directly on IC without any legacy IT infrastructure, centralized infrastructure, and so on. So I'm going to cover a few small superpowers of IC, just so that you have put things in context. So the first thing is what we call as Canister smart contracts. So think of them as an evolution of smart contracts, which are more designed for more general purpose applications. So what can it do? It's super fast, runs at web speed. So remember, all of our nodes are hosted out of data centers in different parts of the world. Why we do that? We want the chain to be highly performant. So 99.99% availability, 10 gigabytes per second, bandwidth, high throughput. The most interesting aspect about canisters is it also holds gigabytes of data, not just like a cold store, but this is the data that's available for your program to build upon. So imagine you're trying to build something like a Facebook equivalent on a blockchain. All of your user feeds, all the pictures, and so on, it's just like they could just exist within the smart contract itself. So let me just answer that question, trivia question now. So it costs almost $100,000 to store a single phone photo on Ethereum. It costs about $500 to store it on Solana. And it costs less than 2 cents to store it on ICP. That doesn't mean that these chains are inferior or superior versus each other. I just wanted to put things in context. If you're trying to build a complete end-to-end application, you just cannot do that with the architecture of, let's say, the legacy blockchains. So what is a canister? So canister is a smart contract that runs a logic, which is your bytecode. Effectively, we run a WebAssembly execution environment. So you can program in any language that compiles down to WebAssembly. It could be Rust, C, Motoko. We have like people who have started building in TypeScript and Python. So you just compile it down to WebAssembly, and it can run within the environment. Also, it has data and memory pages, which is like the gigabytes. Every single canister has about 96 gigabytes of data available today, where you can store all of this stuff, which is used for your program. So IC smart contracts can help you implement basically just about anything. Chat and messaging, social networks, metaverse, 100% completely on-chain, replicated in a blockchain kind of an environment. So what's the use? Like, what is it that you can do combining that? Why do you need to run these kind of things on a blockchain? So here's the concept of open internet service. So when you think about a typical application, the one on top, right? So you can see how does a software developer develop an application? So they would write some piece of code, use something like GitHub, and push that code open source, and the application is running. They can obviously change the code. Community can contribute through PR requests and whatnot. We are talking about a completely new paradigm here, where we can say, how about your entire app can be governed by the token holders, a DAO. There is no CEO, no founder. So the DAOs are not just for managing the treasury. The DAOs are actually contributing to every single aspect of the app. And so this entire thing is running in a Canister smart contract all the time. So I'll give you a couple of examples. This is a chat service. You can play with it. It is like all live. So it's a messaging app very similar to what you would call as like WhatsApp or WeChat and so on. But it is actually governed by token holders, by a DAO. There is no CEO, no founder. There was a set of team that created the initial code. And now it's completely decentralized, governed by a community of token holders. So what does that mean, right? So let's take an example. Say you are a token holder of OpenChat. You can say, I want to change the theme of this app from dark mode to light mode. So anyone can write a piece of code, submit it as a proposal to the community. As soon as the proposal gets accepted, the app automatically changes from dark mode to a light mode. So basically, the community decides what happens, how do you write code, and so on and so forth. Every single thing, every message that you send is essentially a blockchain transaction. It's an update call which updates the smart contract. And it can also double down as a chat message. So you can store crypto. You can store ICP, Bitcoin, Ethereum, these kind of assets, completely non-custodial wallet. And you can send this as chat messages to your friend. Now, this kind of an application, I've been in the blockchain space for a while, but I haven't come across an application which can be built completely on-chain. So this is an example. This is a team of Indian entrepreneurs. They are building a decentralized version of TikTok, but with a very interesting crypto spin. So what they are doing is that they have created a decentralized economy. So as people, what we can do is if you're watching a certain video, they give you an option to contribute if this video is going to go viral or not. So you can bet some tokens and say, if this video goes viral, then I basically make more tokens. If the video doesn't go viral, then I lose. They've also done things like enabling the community and brought them together to do content moderation. So content moderators are just basically crowdsourced. They watch video, they earn in tokens, and it's all distributed through this entire paradigm. This team did a decentralization auction where they sold some of their tokens to the community, and they raised about $5 million a couple of months back, completely without any VC funding, 100% on-chain. So there's a whole grassroots army that's now trying to build on the internet computer any form of Web2 service that you imagine. There is a Web3 version being created, of course, with very different crypto angles, like I was explaining with Hot or Not. So you can build, let's say if you're trying to build a team like Discover, which is like a Reddit-style social network, they help you build NFT-gated communities. So if you own a Bored Ape, then only you can participate in that kind of community, and so on and so forth. So the takeaway is you can build fully end-to-end applications, host all your front-end experiences completely on-chain. Now the next question is OK, what happens, right? So I have put this infrastructure, but blockchains are typically silos. So they cannot interact with, let's say, external web. They cannot do API calls to a Web2 service to fetch, let's say, Google Maps or something like that, right? So one other interesting aspect of internet computer is users can directly interact with these smart contracts simply with a browser. So you type in the URL in a browser. You do not need a wallet, because the developer foots the bill of gas computation. So it's a reverse gas model. And you can just start interacting with these apps without any wallet. The smart contracts can also do HTTP out calls. So basically, the idea is you can just create an asynchronous call to any Web2 API and say, OK, I want to fetch this data, whether it's a price data or, let's say, like location data, latitude data, any Web2 service, you can just call in, make an HTTP request and get the response. So it can interact with the Web2 systems. So this is how it works. All of the different machines, They make a request to fetch that data, and then come to run a consensus on it, and then present the result back to the users. Now, this is one of the most fun piece, which we are excited to talk about today. So now what we have done is we have solved the problem of, OK, now you can build these experiences on chain. You can also interact with Web 2 systems. So imagine a crypto cloud where you can host your applications, fetch data from Web 2 systems. But what about other blockchains? I mean, Bitcoin is not going to go anywhere. Ethereum is not going to go anywhere. All of these different blockchains are doing very cool stuff, and they'll all probably coexist. So when we started this project, one of our key vision was like, how can we bring it all together so that this universe can simply, seamlessly interoperate without any bridge? So Canister smart contracts can directly own crypto. Now, this is a big deal. What that means is that every smart contract on internet computer can have a public key for Bitcoin, Ethereum. So you do not need to bridge anything or try to wrap things like that. Simply send a Bitcoin to that public key address, and you have it like the smart contracts on IC can hold it. So say you're building a chat app, you can say, like, send me a Bitcoin, and people will be able to send you a Bitcoin directly because they have the public key. And the private key is managed by the network itself. So a bunch of nodes in the replicated state, or essentially the client, they keep a small share of like a key material, which is never shared, but they all come together in a threshold way. So let's say there are 30 nodes. 10 of them would need to come to create a signature, help you send that Bitcoin over. So basically, they can create accounts on other blockchains and sign transactions. So you can send a Canister smart contract, Bitcoin or Ethereum. You can hold it there, and you can ask them to transfer from one person to another by creating a signature. All that is done without any bridge, completely on-chain. So as it stands today, ICP is fully natively integrated with Bitcoin and Ethereum. So all of the things that essentially I spoke about, it fully works within the Canister itself. One thing I also mentioned to you about was like how each of the smart contracts have 96 gigabytes of state that they can maintain. So what we have done is we read the entire state of Bitcoin, look at all of the unspent transaction output, basically all of the balances of people, and we store that in a single Canister on ICP, which can be used by any program that's being built on IC. This is chain key Bitcoin is essentially, so say you want to transfer Bitcoin from one person to another. Of course, you are holding real Bitcoin, native Bitcoin. Each of those things will cost you a Bitcoin transaction fee, and of course, it will cost you the slowness of the Bitcoin network. One way you can do this is you can essentially put your Bitcoin as a collateral and mint a new asset, which represents one-on-one, backed fully by Bitcoin, completely on-chain, and then you can use that for ledger transactions and so on. So it basically enables you to do fast transactions on ICP. This is a big announcement. A couple of days back, we now also support CKETH. So you can essentially send Ethereum and put that as a collateral and use like a ICP ledger to essentially do Ethereum transaction fast, 1 second finality, and so on. So why are we doing this, right? What's the big picture idea here? We want to build this cloud for crypto where the entirety of the system is fully trustless. You host your application front-end experiences on-chain. You are welcome to host your tokens on ICP or keep them on Ethereum. And then you can just simply, let's say from your front end, you can sign a message to say, OK, do this thing with my tokens on Ethereum. Or you can bring those tokens over from Ethereum onto ICP. You can interoperate with these different blockchains in such a seamless manner that has never been possible before. So our mission is we want to see the majority of world systems and services reimagined on a public network. That's really what we are trying to. So we feel software, of course, you would have heard of this. Andreessen Horowitz made this statement, software is going to eat the world. We feel smart contracts are going to eat software. So these decentralized systems are super secure, require less personnel, Bitcoin, Ethereum, they don't need firewalls. They are just cryptographically, mathematically secured. So you just interact with them. You don't need to build all of this IT machinery and all of those people managing keys and access and all of that. That is just simply handled by the math. So that's what we feel it is possible now to do this use the blockchain to reimagine any form of software that exists. So I represent DFINITY Foundation. DFINITY is a 250-person organization headquartered in Zurich with offices in Bay Area and India. So it started back around 2014, 2015 timeframe, came up from the Ethereum community. And so our founder, he heard Vitalik talk about this phrase, world computer. So when he heard that in his mind, I think the perspective was, OK, the world computer has to be where you can really run anything, right? And that's the mission. So it took us 8 years, a long journey. We have some of the smartest cryptographers in the world, like lots of folks from like IBM Research Center in Zurich, a lot of professors, PhDs, and they have been trying to build this protocol, which now we feel we are to a point where we can kind of make this entire vision true. So you can explore our ecosystem. It's available and for anyone to kind of play with. All of these applications are live, so you can see for yourself. Let's reimagine the internet with ICP. And I have a nice, so you can apply for a grant. We offer developer grants, community grants. So yeah, I'll leave you with $4. Let's do it. Thank you.